Welcome back to PEEPanEIP, an educational video series where we learn about an Ethereum improvement proposal, upcoming upgrades, and the basics of Ethereum blockchain. I'm Pooja Ranjan, and today we are going to talk about EIP-4361 Signin Ethereum. To talk about the proposal, we are joined by Wayne Chang. Wayne is a Chief Innovation Officer at Spruce ID and is one of the co-authors of the proposal. Welcome to the show, Wayne.
Thanks for having me. Really appreciate some time. And that's a little tongue-in-cheek Chief Innovation Officer, because it sounds like Chief Innovation Officer, but really I'm the co-founder and Chief Executive Officer. So just wanted to be clear about that.
That's right. I just took it out from your Twitter profile, but I'm hoping to hear more about it. Thank you for joining us today. And let me just give a quick introduction to the proposal for our audience. EIP-4361 is a standard track proposal of ERC category. It was documented in October last year and is currently in draft status. However, there is an open pull request for it to be moved to the review status. We'll get to know more about the proposal and about the status in this episode. Sign in with Ethereum sounds intriguing, and I'm looking forward to learning more about the proposal. We'd love to hear a little bit of background of you, how you found Ethereum and got involved with this proposal. And yes, of course, the title that you just mentioned.
Yeah, of course. I have slides I can share after this brief intro, but yeah, so my name's Wayne. I'm working on Spruce. Spruce has been around for almost 1.5 years now. We focus exclusively on decentralized identity, the idea of letting users control their data across the web. We think that public-private key infrastructure is probably one of the best ways to do it technologically. And I'd say that Ethereum and EVM compatible systems probably the most successful one we've seen to date. Really excited to figure out the potential there. And before that, I worked at a company called Consensus, also working on decentralized identity. Actually, when we were exploring decentralized networks and trying to figure out how to make things more peer-to-peer, one of the big problems that came up over and over again was identity. Because if you look at a lot of the centralized platforms today, they actually serve an important purpose, providing trust for interactions. So everyone who enters the platform, there's some kind of level of vetting that happens, right? You're able to get into strangers' cars or get into strangers' apartments or vice versa, right? And it's because what makes it possible is a bunch of checks and buildup of identity within these platforms. So as we move to a world where there are fewer central platforms to lock people in and really more coordination happens peer-to-peer, we think that data must also move decentralized. So you can know that someone has a valid driver's license or they have a good reputation on the network before you step into their car, right? So ideally, this doesn't happen through an omnibus kind of provider, but instead it happens to peer-to-peer, just like the transactions. So that's really the future we want to move towards, where users gain more control over their interactions, not just crypto assets, but also other aspects too, including signing in with Ethereum. So I can share my screen and walk through some slides for y'all, but really excited to talk about it.
Thank you for the introduction. It's pretty interesting, the backstory here. And yeah, let's peep in.
Okay, great. Let's dive in. So we're going to go over an overview of the project, what we're trying to do with it, history of the project, how it got formulated in the first place, a review of the spec itself. We're going to go over a laundry list of security considerations. There are a lot of them, and we take them seriously. We have to start somewhere, and we're going to keep getting better. And then next steps, what are extensions and future things that we can do with EIP-4361? So signing with Ethereum, we abbreviate as SIWE, as in C, yes, and we are going to make it. In fact, we're trying to do a cute seaweed inspired logo for it, but hopefully we can get to that soon. It's a new form of authentication that lets users control their digital identity with their Ethereum account and ENS profile instead of relying on a traditional intermediary. So you might be familiar with buttons that say, sign in with Google, sign in with Facebook or Amazon. What if instead you could sign in with your Ethereum account that you already have? And if you're an Ethereum user, you're probably pretty decent at managing your keys already. If you have digital assets that you use, and if you're not, you should learn how. And basically, you can also use those keys for other things than sending assets around or interacting directly with smart contracts. what if you could sign an authentication request to log into a service, right? That's the whole idea behind signing with Ethereum. It's not a new idea. It's been in production for years, I think. If you look at OpenSea, for example, you try to go to your profile for your account, you try to edit some details about yourself. Basically, OpenSea doesn't want you to edit your details until you've proven that you're actually the person behind that account, right? And how you do that is signing a login message after you connect your wallet. And then you can get an authenticated session and you can update the stuff, your metadata in your account, like your profile picture or your alias, stuff like that. So it's already happening in the wild. We've just seen pretty huge variety as to like how people implement sign-in with Ethereum. And that's why we thought it was a perfect standardization opportunity. Basically, we had everything from really nice requests with issued at times and challenges or nonces to prevent replay attacks to things that were just like login in all caps, right? And they made the user sign that, or even worse, it was like a random hash message that the user couldn't possibly get any idea around, and they were expected to sign this and it would do things, right? And that is highly suspicious, because when the user doesn't know what they're signing, that, you know, all sorts of problems root from there. So in an attempt to standardize this and have one message form that people agree upon, you know, that's why we worked on signing with Ethereum. A little bit of history from signing with Ethereum. I think one of the earliest ideas was actually thoughts around this were by Brantley Milligan at ENS, who I think like way back when, you know, months ago, sometime last year, tweeted out that sign-in with Ethereum has all this potential. And it was this great tweet thread about it. And a lot of those tweet threads go nowhere, but Brantley decided to actually have an RFP, a request for proposal, and you know, got interest from Ethereum Foundation and ENS for it to co-sponsor a grant to support this development. Who's going to standardize this and write the reference libraries? Spruce submitted a proposal, and fortunately ours was accepted, so we started the work late last year. And basically, the purpose is to provide a self-custody alternative to centralized identity providers for the users who want it. And with an increase of control, users do accept an increase in responsibility, because if you lose your key, it's very problematic. There are ways to make this better, but that's a whole industry-wide issue that a lot of people are working on. And we just think that there are certain incentive compatibilities that you can enable better if the user has a direct authentication relationship with the service instead of going through an intermediary, right? Especially if the intermediary you're going through, you know, likes to make money off of the information they collect on you, or you know, try and influence your behavior in other ways. We much prefer this kind of peer-to-peer mode of interaction, and that's why we're really interested in working on this. So we're really fortunate to have worked on it. So what is the specification? What does it do? It's actually pretty like tightly scoped. We believe in solving one small problem at a time. This is a very important small problem, but we tried to rein it in. We see a lot of attempts at these overarching identity systems, like this is how the world could work. You need to adopt these emerging standards and everything. We were kind of like generally not so excited by that direction, because usually when you make someone have to buy a whole ecosystem just to get any value out of something, it's really difficult to get adoption. And this is something that you really need network effects to be effective. So what did we do? We just decided to standardize the message format that the user signs in a really rigid fashion, so that we can make the trade-off between the user understanding what they're getting themselves into, signing into a website with their Ethereum account, and also the machine being able to enforce security requirements around it, provide extensibility opportunities, and standardize how some fields can be collected. So basically, after authentication, the server can fetch more information about the user if they want to get their public blockchain activity, such as if they're an NFT holder, or even fetch from private sources, because not all data belongs on the blockchain. And I think that's very uncontroversial. I think that there is a narrative I want to dispel, that people think that, your identity is going to be fully represented as NFTs on the blockchain. I think that's really untrue. NFTs might be good for some public facets of people's lives or informations, but I think private is the right place to start for people's data, and extremely selectively revealing what they want to disclose to the public. That's how we achieve privacy. And so making sure that we have room in the spec to extend for these use cases as well is very important to our work. And the message looks like this. It is not too different than some of the specifications, not specifications, but implementations we've seen in the wild, intentionally so. Again, trying to balance that act between what the user sees and what is machine readable. For people used to some more established technologies like JWTs, JSON Web Tokens, defined at IETF, you'll notice that this is actually like a specialized JWT. We have even very similar field names, issued at, expiration time, not before, and also are able to specify nonce to prevent replay attack. So this is the general message format, and you can have some variations. Certain fields are optional, again, to improve readability, but it's required to be displayed in a certain order. I can stop here if anyone has any questions.
So taking a look, it looks like you mentioned, that this seems very similar to JWT. Does that mean that sign in with Ethereum also might work with something like oAuth in the future? Could literally be in the same list as like sign in with Google, sign in with Facebook?
Yep. So I'm actually excited to talk about this part too. I'll touch on it and we can revisit it for as long as you like. But basically, it'll be really hard for Web3 wallets to issue JOTs or JWTs because it's just kind of not on their product roadmaps, right? But they do support personal sign, and convincing them to issue JOTs, it's kind of one big product discussion nightmare. But if you have a very specific thing, it's much easier to talk about. And with respect to oAuth or OpenID Connect, part of the deliverables actually was an identity provider server implementation that was compatible with OpenID Connect. And we have also implemented that in Rust. So the challenge here, though, with the current OpenID Connect specification as it stands today, and if you ever click sign in with Google and get redirected, that's OpenID Connect working under the hood. I think Facebook technically does not use OpenID Connect, it just uses oAuth 2 with some custom claims on top or something, but I digress. So when you're using OpenID Connect, the assumption is that there's another server somewhere that is responsible for your authentication, right? And how that works is that you get redirected there from the relying party. The relying party is whoever's trying to rely on that authentication information from your identity provider. So you get redirected to the identity provider, you sign in there if you're not already, and you get redirected back if it all worked, right? And the problem with sign in with Ethereum's fit into this model is that model assumes a centralized server today. And basically, were we going to host a centralized server if the whole point is to move things peer-to-peer and not create another intermediary, right? So we think the middle of the ground solution here, and why it's important, is that certain services want to integrate just another identity provider. They have like a configuration file. They don't have to implement a new authentication method, which is what this is. They can just add a line in their configuration file next to the 3 other IDPs or identity providers they support, and they want to do it that way, right? So to make it really easy for people who only want to integrate support for sign-in with Ethereum like that, we think a good middle of the ground solution is to figure out how to get a nonprofit, a foundation, some kind of credibly neutral entity to actually run an instance, a secured instance of an identity provider server, so that there's no incentive misalignment with the user. And if the user trusts this intermediary, then they can decide to use that service. But we do recommend direct authentication where possible. This is also how like WebAuthn works with Fido. But does that help, William?
Yeah, that does help a bunch. And like you said, if you're going to talk about it later also, so we can revisit other applications there too.
Okay,
thanks a bunch.
So some things we wanted to talk about, EIP-191 versus EIP-712 was an important decision made. ABNF conformance, why we picked that, and also EIP-1271 compliance. So I'll go over give a refresher on what each of these things are and kind of talk about how they relate to this spec. When you're signing stuff with Ethereum, Most people will sign Ethereum transactions that are interpreted by the blockchain as, a valid transaction on the Ethereum network, and it will do things, interact with smart contracts, etc. Right? What if you want to sign stuff that's not an Ethereum transaction? Well, EIP-191, and I think Nick Johnson was an author on this from ENS, basically has a prefix that goes in front of the message you're about to sign, and you're required to put it there so that that message can never be misinterpreted as a valid Ethereum transaction. So you can sign something that's not a transaction for sure, right? And then it did not specify what happens after that. EIP-712, not to be confused with EIP-721, which is the NFT standard, but 712 specifies structured types for data signing. And this is actually, I think, on top of one-on-one in many implementations, where we are defining how to create fields to sign, right? Like if we want an expiration field, if we want like an account address field or something like that, we have a structured way to add fields that are typed. This one's a string, that one's an integer, right? And it also has recursive type definitions and some really interesting things in there. And basically, from a security perspective, wherever possible, you should lean towards a more structured data format because it's tighter. There's less room for error and less room for multiple interpretation, which leads to security bugs. There was a format called XML DSIG, and because there were multiple formats of it that could come to the same signature, right, and verify that the same way, there were classless security bugs introduced because of this ambiguity and flexibility in the format. So you want the format to be really tight, so that there's little room for misinterpretation and you reduce the number of security bugs that are possible, right? EIP-712, adding structured data types could help with that. But we found that when we try to display the EIP-712 message to wallets today, we have a whole research report on this. It's basically really difficult for the user to understand what they're doing. It just barfs out on many wallets like a JSON blob that has a huge EIP-712 header that doesn't contain any information about the signing, just some kind of like setup work for this, the type data structures, right? And we found this to be pretty horrible from a UX perspective. Not only would the user not really have a great chance to consent to what they're doing, but also for the applications that we're trying to talk to use sign-in with Ethereum, it would actually degrade their user experience far worse than what they already had. And that would just kind of be a non-starter for a lot of these applications. And then you have this cold start problem where, oh, well, if we get the wallets to talk EIP-712 and display it nicely, then maybe they'll revisit. But who's using this on the application side? Ask the wallets, so you have a big cold start problem with that. That's why we did two things. We decided to go with three things, actually. We decided to go with EIP-191. We added a version field as part of the message format for this. So right now we're on version 1. We go to version 2 in a world where EIP-712 is everywhere and abundant and great UX on wallets, then that's something that we consider for version 2. But version 1 will always be EIP-191, and this plain text message we've rigidly defined in ABNF. And this is a grammar specification at IETF. It's been used over 30 years in a bunch of other specifications. And basically it lets you define rigidly this message format, saying things like, this thing must be a URI, this version must be a number. We are particular about the new lines and how many new lines you have to have after a statement, even down to the format of like an Ethereum address, right? So that is how we're making the compromise between something the user can understand and something that the machine can unambiguously read, and make sure that we have those increased security properties. So EIP-1271 compliance as well. So what is EIP-1271? Well, it is basically a standard for smart contract signature validation. And what does that mean? It means that so you want to sign messages and you have a key. Okay, cool, that's great. Just sign the message, right? what if you're a smart contract and you don't want to put a private key in the smart contract because then everyone can see it, right? So how does a smart contract sign things or validate that it was a good signature produced, right? And EIP-1271 is a standard that basically is supported by, I believe, Argent Wallet, Gnosis Safe, and a few others as to how to validate a signature with a smart contract. It is theoretically gasless because it's an RPC GET call, right? So it's read-only, and it requires you to define one function called isValidSignature, where you pass a hash of the message, the signature, and it'll tell you if it's valid or not, and that's it, right? So you can imagine how to implement this with a multisig, right? You might require like M of n signatures, and what the GET request can do is look up the current list within the smart contract of valid members of the multisig and make sure that at least M of n of them signed it, all configurable within the contract. This way, the people can produce signatures off-chain, and they can verify the message and signature pair on-chain, well, not using a full node or a RPC GET request against the node. So that's basically what 1271 does. It allows you to use signing with wallet-based on smart contracts. So the fact that Sign-in with Ethereum supports this means that we also support multi-sig login, or how does a DAO log into stuff, right? And this is something that is great. Also, it's great for key management. Key management we'll talk about in the security consideration section more, but it's probably one of the most important problems for the whole industry to solve. And we've seen great progress over the past 10 years. Basically, people being able to manage their keys. Some of the most innovative solutions around improved key recovery, in case you lose your keys, what happens, right, uses multi-sigs, and many of them use EIP-1271 as well. So having the benefit of being able to rely on the really quickly growing ecosystem of key recovery solutions based on contract signing, that's really exciting. We definitely wanted to support that in the spec. We think that's really great advances in coming with respect to UX and security. So we believe that session should be bound to key material and not necessarily ENS data, but we encourage the resolution of ENS data to load a user's profile if that's how they expect to interact with you. So after a user authenticates, or even before, they just connect wallet, you see that they claim to have a certain address, but you're not sure that's really them, right? Signing with Ethereum is different than just clicking the connect wallet button, because when you do that, all it does is reveal, I have this address, right? And anyone can write a browser extension that implements the same API and just can claim they have any address, right? So that alone is not enough to authenticate a user for services. You want to do something more. You want to do sign in with Ethereum after Connect Wallet if you want that authenticated session. So it can happen before and after, but the semblance of it happening after is that you get to see that, this is authentically the user. You can start deciding to give access to someone if they have a certain .eth address, for example. You might be able to use other aspects that they controlled about themselves to decide what kind of role they can adopt in your system. We saw a really cool WordPress plugin that someone piloted where they automatically mapped, I think, like NFT ownership or DAO membership to roles in WordPress. So you could sign in with Ethereum to a WordPress site and then automatically be assigned roles depending on what basically DAO membership you had or something. And from that, you could take advantage of the whole kind of role permissioning system that WordPress has had for years, right? And it's been proven pretty secure. So that's really exciting. And I think the most exciting thing about that example and many of the sign in with Ethereum examples is that no one had to ask, like the person who minted the NFT or something, permission to provide an improved user experience for those users. They could just implement sign in with Ethereum, and after authenticating, read the data, and bam, you have like a portal for that community. So that's pretty permissionless to be able to just integrate like that. Also, basically with the combination of ENS data, you'd have a public profile you can take with you, across the web. If you sign in with Ethereum, load your information. It's kind of like Gravatar, but with another growth trajectory ahead of it. So we're really excited about this combination too. So just some terms. We went over what a relying party is, but just as a refresher, it's someone who's trying to rely on the session data. So a server that wants to make sure you are who you say you are before giving you advanced access. So they will verify the sign with Ethereum message format that we specified and create a session bound to the address. Typically, this could be a cookie-based session, so it works a lot like Web 2. There's something called session keys that we can talk about later as well as another way to do that, and interpreting and resolving further resources associated to the account. On the wallet side, it's important that the wallets verify the message. They verify domain binding, which is really important for security because right now, one problem with implementations not using the specification and conforming to it is that you're susceptible to man-in-the-middle attacks. Meaning that if someone's like example.org wants you to sign in with your Ethereum account, right, and that message is produced, it could be displayed by an intermediary, and the user could click sign with their wallet without any kind of, consequence in the UX. So that allows whatever intermediary that performed the man-in-the-middle attack to take that signature and authenticate as the user, right? And that's horrible. So in order to prevent this horrible outcome, we really want to work with wallet providers to help users verify domain binding, meaning that you're checking that you got a connection through TLS, and that you're actually on the domain that the message is requesting the signing for. And that would really, really help solve this important security issue. There are other ways to look at this problem, but it all involves we need the wallets to help protect their users. And another thing that wallets can do is create very user-friendly interfaces once they know the message format to expect. Right? Instead of just signing a blob of text, what if you can interpret parts of the text and display a really like semantic UX? The user knows exactly what they're doing, right? And then they're able to have a great user experience. We have required fields that have to be displayed to the user on the first display, and also fields that can be available in extended screens. Just looking at the chat comments as well, I just want to reiterate that this is a gasless operation. No gas because you're signing something that's not an Ethereum transaction. You're signing an authentication request. So just kind of additional, like this is the EIP-712 support in certain wallets today versus what we saw in OpenSea about a few months ago. And that informed a lot of our rationale as to why EIP-191 today and not 712. All right, let's talk about security considerations. So one of the top most security considerations, and you can find this all in the security considerations section within the spec, is identifier reuse. Basically, as you navigate the internet and you log in with the same username and password, or kind of load the same tracking pixel that is able to see who you are, you're running into identifier reuse. By using the same identifier from site to site, people might be able to build some kind of profile about you behind your back, compromising your privacy in innovative ways, right? So in order to prevent that, ideally, every new interaction you have digitally just starts with a new, completely uncorrelated identifier. It was never used anywhere else before. And you can just use it for that session, right? You can add in information as you need to tell more about who you are, but nothing more, right? And you've achieved closer to perfect privacy. This is something that, fortunately, we don't have too big of an issue with the current demographic of users that want to use dApps. They basically want to show that they have NFT ownerships, and users of a lot of the Web3 wallets have really good hygiene, we found in some demographics, with respect to having like a different account for a public persona versus for trades they'd rather keep private versus accounts for different purposes. We need the wallet's help, like once again, to improve the ability to create new identifiers per interaction. I think I've seen some pretty interesting work from the Brave team on this, where they had to modify MetaMask, I believe, to create a new key pair for connecting to a DApp, right? And that's exactly the kind of direction we need to move to. Basically, another approach towards the identifier reuse mitigation could potentially be through Metamask Snaps and other similar modules that allow new keys to be generated per session. I think you can access entropy there. So really interested in working with wallets and figuring out what more can be done here. There's also things in the realms of ZKPs and circuits that we can use. If you can demonstrate a certain link to a new identifier, like a pool of identifiers, you're like, one of these owners of a class of NFTs or something, right? And you're able to somehow sign with that. That's really interesting as well. So those are some areas we're beginning to explore as next steps towards working on practical identifier reuse mitigation, but it's definitely a top concern because it can compromise privacy. The next one is key management. As I mentioned, it's one of the biggest challenges in the industry today. And I think that we've seen great progress and we'll continue to see that. I think I mentioned about how when we move to, when we support multi-sigs, we're able to take advantage of a lot of the innovation that will happen in the space. Wallet and server security, we went over a few of those already, making sure that the relying party and the wallet are validating message formats. Most important to me is ensuring domain binding at the wallet level. So we're really protecting users from man-in-the-middle attacks, right? So we really want to advocate for that. And that's why, we hope that wallets will adopt the standard so that their users can be safer. Also minimizing wallet and server interaction. What's really interesting is that there are some ways you can generate the message entirely from the wallet, and you don't even need to ask the server for any kind of information. The fewer interactions you have between a backend server and the wallet, the better it is to achieve potential privacy for the user, right? So how can you do that if we have fields like a nonce or something? Well, what you can do is maybe agree on the latest block hash as the nonce, right, to prevent replay attacks, or just expect the current system time, something like that. So this way you can auto-generate the sign in with Ethereum message on the wallet side, and you can just send one signature to the server with maybe some fields that they should expect and verify that way in one fell swoop. Also, the wallet UX, as it improves, should allow users to have more articulation over the request. For example, setting the expiration time for the session, right? What if the user decided that and not the server, and the server just honored it? What if the user decided, to be able to add some resources additional that the server could access? We have a resources section that is up for interpretation. We're not focused on authorization in this specification. We just wanted to allow the extensibility into there. So there's a field called resources, which is just a list of URIs. Preventing replay attacks with a nonce. I think I already went over domain binding, but there it is again, because of how important it is. So please, wallet providers, if you're out there, consider adopting SIWE so that at least this part is SIWE. And channel security. There's some interesting challenges with Wallet Connect in its current form, because right now you're unable to, when you connect to Wallet Connect, you basically are staring at the other end of an encrypted tunnel, right? And you actually don't know where you are on the other side, right? So how can we add the functionality so you can ask about and ascertain who you're actually talking to? So right now, the user will have to examine, they'll have to examine the domain in their browser as they use Wallet Connect. Or maybe there's some kind of creativity we can get with signed nonces or some kind of signed Wallet Connect requests. I think that it's being addressed in Wallet Connect too. So we're really excited and optimistic about it. And then finally, session invalidation. This is especially important to consider if you're using EIP-1271, which is the smart contract wallet specification, because if you're relying on a multi-sig to log in, right, and the multi-sig group changes, you should probably invalidate all the sessions depending on your security model, but that sounds like a good direction to lean towards, right? So it really depends on how you set it up and what you support. Great. So we've had community involvement, a lot of it, and we're really proud of how it was conducted. Basically, the whole development of the standard, we had reports on the regular to the community in a public, open a community chat every week or other week. We would invite anyone who wanted to hear about it to hear the updates about how signing with Ethereum was going, decisions made in the spec. We had a long discussion about EIP-191 versus EIP-712, which you have the benefit of hearing about here a little bit. A lot of great points were made, including forwards compatibility with new extensions to the OpenID Connect framework. We can talk about that in a bit. And it's all recorded. It's all on the internet. We have notes from every meeting. So if you want to see the evolution of the spec and the decisions that were made based on feedback from experts in the call, we had people from wallet companies, we had end users, we had developers writing apps, we had people who have been working in the identity space for like 20 years, just working on a lot of the SAML systems and the early days of oAuth and things like that. So we're really proud of how diverse the community was and the level of questioning and discussion that took place there. Feel free to look at any of the recordings if you have questions about it. And the top things that we talked about, I just kind of went over, but security mechanisms, pragmatism trade-offs so that we make sure that it's something people can use, different signing formats, and contract wallet support. I think we had like someone from Open Zeppelin there as well, just kind of who actually was implementing a lot of the stuff. So that was really cool. If you want to learn more, it's all at login.xyz, the recording notes, everything. There's even a demo there you can use to see how it works. We have documentation released if you want to walk through how you implement client and server side support. And we have language support too. Basically, I would just talk about the language support a little bit. So you can look at the documentation, docs.login.xyz. It should be pretty apparent on the website if you just go to login.xyz. We have support for TypeScript / JavaScript, Rust. There was an external contributor for like a community contributor for like Python support, which was amazing to see. And I think they're working on Django support now too. So it's awesome to see like independent contributions. Shout out to Afri who implements the Ruby gem for Ethereum support more generally. Basically, I think you just added smart contract support to that. So by using that as a dependency, we're able to support signing with Ethereum and Ruby with smart contract wallets. So there's a bunch of activity and support going on. We're looking and running towards integrations for Rails and Django, WordPress, a lot of these platforms where users have been asking for it. And we've had supporters across all different kinds, as I mentioned earlier. So the next steps are to basically have continued support across the ecosystem, all these different languages, projects, use cases, petition for better wallet interfaces so that users can have a great experience when they're signing with Ethereum, and launching with Web2 partners. I think publicly, Time Magazine and Adobe have said that they're really interested in this and want it on their roadmap. And this is, I think, a moment where users can take more control over their digital interactions, the same way that they own their digital assets. Your keys, your crypto becomes your keys, your data, right? And we're really excited for that to move forward. And there's a lot of supporting pieces in the ecosystem that made this possible. So that's it for the presentation. Happy to move into a more interactive Q&A period. Thanks so much for letting me talk about this.
Thank you so much for this presentation. I remember this RFP going out later during summer or fall last year. I'm really happy to see this into production, and the group is actually working on it. And also the acronym, the CV, that's pretty interesting. Having community calls for proposal is also a very good way of generating momentum. So thank you for that. We would be happy to provide any support if you may look from cat herders to, kind of raise awareness more on that. Already you guys are doing a great job, just adding to it. We can see that there are a few questions in the chat. Let's start from there. Alita, I know you have posted a bunch. So if you would like to go ahead and read any for the guest.
Yeah, so I'm gonna ask you some questions. Okay, so the first one I asked was, I think one of the most, well, it's pertinent to my life right now anyway, because I've been having problems with SMS authentication and like the reliability of that, and so I'm wondering if you see this as playing a role in like authentication space where you can have like, for example, like maybe you sell like a hardware wallet that can authenticate all of your things in the same way that, a key fob could.
Yeah, absolutely. I think that's a really creative application of it that would work perfectly. So a little context, SMS authentication, meaning you get like a text message and then, it has a unique code for you to finish your login. I'm sure everyone's kind of encountered this before in their lives sometime. And then people tweet about how Apple's so good at reading the code and putting it into the box for you. But aside from that, it's been pretty recommended against. I think the federal recommendation in the US is like new security systems don't use it because some jacking, a whole bunch of other things. There's kind of a counter argument about accessibility of SMS, and a lot of people have it. But I think it's something that people acknowledge we should deprecate this and move to something better. Something better could be signing in with Ethereum in addition to your normal username and password, right? What if you could use sign in with Ethereum as a multiple factor in your authentication? So I think that's a really great use case.
Yeah, I'll ask one more question, and I'll kind of add a bit of my own thing. The reason I have a problem with SMS authentication is because when you change your phone number, it eventually gets recycled, and then therefore somebody now owns all of your accounts, some random person, which is what's happening to me. But anyway, a question from, does the on-chain infrastructure require high-check clients? I know you mentioned that the wallets, and this is actually related to another question I was asking as well regarding security of the clients. But I'm wondering like if, from one thing I've seen during my time in Ethereum is that there's a lot of discussion and a lot of like kind of delay with respect to the communication between clients and the core developers and the development community in general. Because you kind of have to do one thing and you have to make that change on all these different clients, and it's just kind of a nightmare. And so I'm wondering, like, does the implementation of sign with Ethereum require that wallets maintain their own code, or is it as simple as updating their package?
Yeah, so I have, let me give a detailed answer to that. A lot of points you hit on there, extremely valid ones too. And we see this with any kind of like standardization efforts, especially with multiple client implementations. In fact, I think like 20 years ago, these same discussions were probably had with all the browsers and the web servers out there in terms of, oh, now all the browsers have to like update to, read like this new HTML tag or something, right? And kind of same kind of challenge here. I think what we learned is like the hardest part of doing this was actually the human coordination and doing over like 80 interviews with companies to figure out what they cared about and what would work for them, right? But like by having the community call and a watering hole for people to gather around, it's actually been like really convenient to get a lot of those conversations going on in the first place and just kind of being communicative about the changes, the benefits to users. Going on excellent programs like this to talk about it too is extremely helpful. So basically, that's one part of it. In terms of the technical upgrade process, yes, we are planning to basically make it as easy as importing a library and checking a message format and not having to maintain that part of the code, making sure that we're defining a good API around the whole sign-in with Ethereum process, whether you're a relying party or client. We imagine, though, that clients or wallets will basically want to give a really great UX as more and more relying parties adopt sign-in with Ethereum. because it's actually a benefit to their users, and the user's more likely to pick a wallet if they value using sign-in with Ethereum to stuff, and it's a great experience, right? So hopefully there will be its own momentum for that. But with respect to the message format and the cryptographic verification, we're hoping to just do a really good job with the libraries there, including considering formal audits and bug bounties and such. But the code, fortunately, is so small that a lot of the security engineers that we've talked to at people who want to adopt are actually pretty comfortable with it already. Does that help with your question?
Yeah, it does. And then I hope you guys don't mind if I ask one more.
Please, this is great.
So one of my other concerns, or one of the things that kind of, a flag or whatever, a concern flag for me would be like the traceability of accounts. So you have an Ethereum wallet account or what account, right? And then you're able to see that account has a account with this Google account, with that Facebook account, and then you can kind of correlate all of these things to one person. And I think that well, first of all, let me ask you, is that possible in the architecture that SIWE has built or is planning to build? At the very least.
Yeah, SIWE implement, it just describes like a message format for signing. So if someone implements such a system where, they're tying all this data to the user and asking the user for that information, then it is possible. Identifier reuse is the top concern under the security consideration section, though. And that's really, I think, related to this correlation of other data. I think that we should move towards a system where you hopefully get a new identifier for every interaction and just populate the session with the data that are relevant. So that's definitely the direction I think we need to move, and we have to be very cautious about implementations that are trying to tie together a bunch of this data. Okay.
So then, in other words, sign-in with Ethereum is not currently focused on like maintaining the traceability, or you say that that's a high priority security concern that is not yet addressed?
Yeah, we have to solve things one block at a time. And here we define like authentication message format. That's not to say we, aren't focused on other like ways to address the identifier reuse thing problem, but I think that for the purposes of this spec, we're trying to keep the scope constrained to just that. The best we can do within the spec itself is call it out as a big issue.
That makes sense. Thank you for explaining.
No worries.
All right, I see a couple of more questions in the chat. Anyone on the call, if you would like to read the question for the guest? Maybe we can go ahead and read the question. I'm not sure if this has already been answered. So if you would like, you can definitely repost the question for the guest to look into it itself. But I'm reading the question that is there from Jose. Looking into the top, the question, are there any fees involved? You already did mention about there are no gas, but is it a monthly payment or each time user validate his ID?
There are no fees. Period. No monthly fees, no like signature fees. Basically, you're signing a message that's not an Ethereum transaction.
All right. I see, Shashank, you have a question that you have posted recently in the chat. Would you like to read it for the guest?
So my question is essentially, so Metamask recently released a developer wallet. It's called Flask, and they introduced a feature called Snap, which is very cool. Basically, you have sandbox JavaScript running. So what do you see that might be currently limiting, depending on the Metamask functionalities, that sign-in with Ethereum project can use in the Snap versions eventually? Right.
Great question. I think this is really a great discussion because it's related to Alita's earlier points about correlation for the user, right? So one of the really cool things that I like about the Metamask snaps is that you can derive additional like entropy from the API they expose, I believe. At least that's my rough understanding of it. Yeah. And that you can generate a new like Ethereum address just to log into a specific service, right? And maybe for that specific service, you only want to show that it's also tied to your Twitter account, and that's it, right? And then for a different service, it's yet another identifier that you generate, and then you're able to tie it to a different set of information that is appropriate, right? So, and there are privacy improving techniques to take these signed claims about things, like I have this Twitter handle and digitally signed, and basically selectively disclose smaller pieces of it without showing the whole thing. So I think like I'm really excited for the potential of snaps running secure JavaScript to help us achieve this more articulation in the session establishment.
Yep, that'll be it. Thank you.
I see there is another interesting question. It was pasted earlier. Does this pave the way for users to be able to sign into a website without having to install a browser extension? And the person is particularly interested in how this could be a UX improvement for centralized exchange users coming over to the DeFi space.
Yeah, so I think that's a great two-part question. So one is kind of like, is this going to work without a user installing a browser extension, right? And I think the answer is like, it would already work in some browsers that naturally support wallets. For example, I believe Brave supports wallets. I don't know the status of their EIP 191 signing. I know Opera supports custodial operations as well within the wallets, within the browser, actually. So, you know, what's interesting is that some browsers would already support it without an extension. There are other ways to do it as well. I haven't researched the security implications of them, but there are solutions like Magic Link and Taurus, now known as Web3 Auth, that allow you to construct basically a embedded iframe wallet or similar, or and you don't need to install a browser extension to use that. Presumably, if you sign in with Ethereum message, it would work the same way. So yes, there are ways to use it without the wallet extension. Secondly, going from Coinbase or Gemini or FTX, Binance, any of the large exchanges that that people are using to a more decentralized version is really an interesting direction. First, maybe using even your Ethereum address as multi-factor, as mentioned earlier, could be a cool idea. But as you want to, maybe associate a specific Ethereum account with your exchange account, you're able to do that. You have to be cognizant about what you're telling the exchange, though, because your other data are linked there. So I would super caution that. But we could see a world where like maybe you can participate in airdrops or anything from the exchange wallet if you link the right Ethereum address to that account. Right. That could be a really cool way for people who use centralized exchanges to get some interaction with the DeFi markets or NFTs or anything like that. So I think there's a lot that can happen there, and it could also lead to a gradual transition from exchange assets to easy export to your own accounts. How terrifying is it today to put in like your address to send the funds to, and then you click send and cross your fingers and refresh Etherscan 500 times until you get it, right? Versus if you sign in with Ethereum and they really like checked that you could authenticate with it, then they sent the funds, right? Like that could be that could reduce a whole class of errors already, preventing people from sending things to weird smart contracts or whatever. Hopefully that helps.
That's pretty interesting. Thank you for the answer. I was about to get into some process-related question, but there is another very interesting question coming up in the chat. If you would like to quickly respond to that, would it be possible or any other further integration support for extending the sign-in with the Ethereum to physical asset that have some communication there, like Wi-Fi, Bluetooth?
Yeah, absolutely. It's just a standard message format, and it can be relayed over any communication channel you wish. But you'd have to think about the implications of using non-TLS things, like what kind of Bluetooth security, if you're using IoT with MQTT-LS. That these are some of the considerations you'd have to make, but there's no reason why IoT devices wouldn't be able to support it, for example. So I think that I think it's a really, I think we even saw a demo of it over like machine to machine, like server to server sign in with Ethereum, right? Just uses the message format and doesn't show the user, but they use it to establish the session. So really excited to watch it evolve.
That's right. Thank you. And yes, as you mentioned about the demo, we would like to add all resources that are relevant that you can share with the community. If you can provide me after this call, I'll be adding it in the description section for people to follow. I know we are very close to the end of the meeting. So let me just quickly go over a few questions which are related to process. I know there is this pull request up to make it into the review proposal, but the proposal itself has started getting a lot of attention from the community, and there are a lot of questions coming up in the Fellowship of Ethereum Magician thread. One of the key questions that caught my attention was attaching an identity to a private key. Do you see this as a concern, or has it already been addressed?
We talked about this at length earlier, and it has to do with identifier reuse. I think that we would definitely caution against tying all elements of an identity to a single key, but I think that per use keys, disposable keys, is the way, right? And I think you run into huge privacy issues if you're trying to just have a forever and always key and use it for everything.
That makes sense. Thank you. And there are a couple of other questions. One of them was related to reference implementation is not in line with the spec. Do you think this has already been addressed in the review when we are having this pull request for review status?
Yes. So the issue in the GitHub repository made was referring to a regex implementation, which is not used in terms of the actual library. So if you install the library and use it, we literally use the ABNF grammar that's in the spec and interpret it using an ABNF grammar interpreter. And that's the TypeScript library. And there have been no issues with that because we found the ABNF library to be correct. We do have regex that helps also do the same thing to show that you can have a much simpler implementation, but also check the message validity. I think there was like a nuance about like a new line or some kind of optional term or something that passed the tests, but I think was technically out of compliance. So that's something that we would want to iterate on.
That's nice. One other question about the proposal. This particular proposal lists a lot of proposals as requires, like they are added in requires section. Most of them are already in the final status except for 1328. So I'm curious to understand how much dependency of 1328 is there on the proposal. I do remember that you mentioned wallet connect a couple of times in your presentation.
I think you raise a really good point, Pooja. I don't know if we need to actually include that in the list because I think, sorry, what was the number again?
1328.
1328. So that one is the Wallet Connect standard URI format, and there's actually like no normative requirements around using that in the spec. So it might be actually superfluous. We can get rid of it. So thanks.
Yeah, that would be helpful because to move any proposal toward final status, we generally recommend the proposals, those are in the required category, must be in the final status. So, I mean, if there would have been any hard and fine requirement of it, then we would have requested you to probably push the other proposal to get alongside to the final status.
Yeah, for posterity, though, we're very excited at the prospect of having a standard Wallet Connect standard URI format. So, Liggy and Pedro, if you're listening, please continue your great work.
That's right. All right. My final question is about the readiness of the proposal. How far the proposal is getting from ready specs? Like, what do you think? How long would it take it to come to the last call?
Yeah, so if you were like, forging a tool or something, I think the general shape is pretty set and we even have some of the finer details penned out. Now it's all about like polishing and addressing things like superfluous required EIPs and things like that. But I think the heft of it is generally agreed upon by the community. Really excited to take care of the last few items and then race it towards final status.
That's really good to know. I love to see this proposal going on. Well, it's time to wrap up. I know we could not cover all the questions, but I will try to send these questions over to you via email and the other ways. We really appreciate you taking out time and talk about this proposal 4361, which in my mind is like a revolutionary proposal, and it's going to be adopted by many dApps in in near future. Do you have any final comment or thoughts to be shared with our viewers or the project developers?
Yeah, login.xyz. It's everything you need to figure out how to integrate sign-in with Ethereum. Join the Discord to talk more about it. And a special thank you for everyone here live today who led that excellent discussion. I really enjoyed talking to everyone here. Thanks for the opportunity.
Well, thank you so much. And on this note, I would like to thank all our YouTube viewers for watching this episode. Please check out the description section for related links. And obviously, we'll be trying to add all demo links, whatever is available. The Twitter profile for the guest is also added here, so you can follow them and ask the questions directly. If you like this episode, hit the like button, share it with people. Sharing is important. We would like more projects to know about this proposal, and hopefully will increase the adoption. Should you have any question, leave a comment. Let us know, even on the ECH Discord, if you would want to hear more about this proposal or any upcoming proposals. Well, subscribe to the Ethereum Cat Herders YouTube